Okay, this is lesson 7.2, logarithmic functions. For logarithmic functions, I need you to realize that the logarithmic and exponential functions are inverses of each other. Okay, so that's hugely important. An exponential function has basically x as an exponent. Oh, I'm running out of room. Logarithmic, I'm spelling this wrong. Is the inverse of it. Now you need to be able to write from exponential form to logarithmic and vice versa. I like to write it out with my little loop-de-loop pattern. Okay, not everybody does, and you don't have to. But I need you to understand, if you see log base 5 of 125 equal to 3, exponentially that means 5 to the third power is equal to 125. And that makes sense because 5 times 5 times 5 is 125. So you need to be able to go from log form to exponential form, and the other way around. So notice on number 2, rewrite in logarithmic form. This actually it might be easier to see. I need you to understand that this cube root of 1/8 is 1/8 to the 1/3 power. Okay, I know it's a little bit harder to see, but you should know already that when you have radicals, you can write them as fractional exponents. So now I'm going to write it from the log form, from the exponential form into log form. So this would be log base 1/8, I know it's teeny tiny right there, of 1/2 is equal to 1/3. So notice it's kind of like backwards of what we did in the other. So it's 1/8 to the 1/3 power equal to 1/2. So you just need to be able to go back and forth on that. Now evaluate the logarithms without a calculator. When it tells you that, it means you can do it without a calculator. So you just understand, or basically the easiest way to do it is probably write it in exponential form. So log to some power is equal to 8. Okay, so I'm going to put equals x out here so we can solve for it. So this would be 2 to the x power is equal to 8. Well, that's the third power, right? Because isn't 2 to the third power is equal to 8? So the answer to that one is 3. On this next one, this would be, I'm going to put equals x because that's what we're looking for, because we want to solve it. This means 8 to some power is equal to 1/64. So the easiest way to solve these would be to get it to have the same base. I know 64 is 8 squared, so this is 8 to the x power equal to 8 to the -2, because remember that if I do the reciprocal of that, it makes it have a negative exponent. So I know that x would be -2, so the answer here would be -2. And then on number 5, I'm going to put equals x so I can solve my equation. 8 to the x power is equal to 1. 8 to the x power is equal to 1. Well, anything to the 0 power is 1. So I know that this has to be 0. There's no other option there. Okay, so on the next little part, it talks about properties of logarithms. These are all the properties that you need to be familiar with. You do not have to memorize the name of it, which is really nice. You just need to be able to use them. Okay, so if you have a log of something that you can factor, basically, then you can break it up to addition, and break it up. The same thing with the division ones. You can break that one up. And the power property is actually really, really good because that helps with solving equations. You can write it, if it has an exponent, you can put that exponent down in the front. Okay, so that is huge, huge, huge. You need to just know these properties. I don't care that you know the name of them, but you need to be able to use them and recognize them and all that loveliness. And we're going to do more on Delta Math with that. Now, on this first one, let's see, number 6, expand this one. And I'm gonna go to the side because we're kind of running out of room right here. Okay, so this would be log base 4 of 3 plus log base 4 of x to the 5th plus log base 4 of y. Now the only thing that you can do now is move this 5 down to the front. Okay, and that's important. You have to do that. So this is log base 4 of 3 plus 5 log base 4 of x plus log base 4 of y. So that is our answer for that one. Now number 7, I'm going to change to a different color just for fun. Okay, number 7. This one, notice, has this exponent out here. So it goes with everything in the parentheses. So this is equal to, if I clean it up a little bit, log base 3 of p to the 5th over q to the 20th. So make sure you understand the exponent rules and can get to that step. So now we have, let's see, this would be log base 3 of p to the 5th minus log base 3 of q to the 20th. Notice it's minus because we have division right there. So it's different than that other problem. So now we put these exponents in the front of each piece. So this would be 5 log base 3 of p minus 20 log base 3 of q. There you go. Okay, next one, number 8. This is the one that we had some issues with in the other class, so let's keep going here. This one's different because you actually have numbers, so you can evaluate these. It's not just variables. So remember that when you see the minus, like this, that is division. When we see the plus, then we're looking at multiplying, okay, when we write it, when we condense it. So let's see, we would have, okay, so we have here, this would be, well actually this whole thing, this exponent goes to the front, right? That'd be squared up here, and that exponent goes up here, so this would be to the 1/2 power. Let's do that first. So now we have log base 4 of 8 divided by 5, and both of those are squared because it goes, the parentheses goes with everything. And then we've got times the square root of 25. Wow, that looks messy. Okay, so let me fix that 8. Much better. Okay, so let's see if we can clean that up. So this would be log base 4 of 64 over 25 times 5, which is log base 4 of 64 over 5. Now we could essentially leave it like this, but you could clean it up a little bit more if you like, and actually say, because I see 64 is 4 to the 3rd power, so we could separate it out and go, okay, this is log 4 of 64 minus log base, I'm running out of room, 4 of 5. So that's 3 minus log base 4 of 5. So you could keep going like that, but I'll accept it like that first way right there. All right, so this next part is the change of base. Now this is hugely important because you can change, solve equations with this. You can change base using your calculator. And basically what this means is if they're asking you to evaluate, like this one, it says evaluate log base 12 of 5, you can't plug it in your calculator, because in your calculator you only have log and ln. You have the 2 buttons. You have, I'm on a highlighter still. Oops. Okay, you have 2 buttons. You have log, and then you have ln. Okay, this one is base 10, This one is base E. So if they give you something like this and they want you to evaluate it and they don't have anything in common, well, there's no, what's the word I'm looking for? There's no common base we can make them have. But you can actually use your calculator and determine the decimal form of it. So this would be equal to log of 5 over log of 12. That's how you can solve that thing. Or you could put it in as ln 5 over ln 12. It's the same thing. And the decimal you get for that, let me look it up, that should be 0.6477. So do it on your calculator, either way or both, and see if you understand how to do that. On this next one, on number 10, okay, I'll draw a line right here. If I want to evaluate that one, it would be log 20 over log 2, or it could be ln 20 over ln 2. Either way, your decimal equivalent to that approximation is 4.3219, I believe. So just check and make sure you know how to plug that in. If you have questions, just let me know and I'll help you out. All right, so let's move on to actually solving the equations. Now, we solved equations with exponents before when we were able to get to the same base. However, we can't on these. They don't have the same base. So the way you solve equations that don't have the same base or can't get to the same base is you use logarithms. You use inverse properties, okay? So you just take the log of both sides. So log of 41 is equal to log of 7 to the x power. So, and you can do ln, it doesn't matter, either ln or log, but whatever you do to one side of the equation, you got to do to the other. Now we're going to use our properties that say we can bring that exponent down in the front. Remember that one? So log of 41 is equal to x times log of 7. And now to get x by itself, I just divide both sides by log of 7. And voila, this is our answer. Okay, now this is an exact answer. Sometimes they ask you for an exact answer. We don't know what it is, but that's what it is. Now, if they ask you for a decimal, a lot of times they do, just plug it in your calculator, and you should get 1.9084. So just do that and make sure you get that value. All right, on this last one, let's see. You can do the same thing, do the log on both sides. So we're going to do log of 0.25 equal to log of 2 to the x power. Bring that exponent to the front. And then divide by log of 2 on both sides. And you get your answer. And actually, if you put this one in your calculator, it does come out to be a whole number, which is an integer, I should say, which is really nice. That means we could have solved it differently. We didn't have to take logs of both sides. We could have used our common bases. For instance, if I wrote that as a fraction, that is 1/4, and 4 is a multiple of 2. So I could have written this as 2 to the negative 2 power equal 2 to the x, which then is the same base. So now we just set them equal to each other, so I know x is negative 2. So you could have solved this one either way, which is kind of nice to know. Okay, on this part, you need to just recognize what all of these pieces are and what they represent. You should be able to recognize them. It should be something that you had last year. If not, no big deal. You can say you heard it here first. But if you have log base b of b, that's actually just equal to 1, because b to the first power is b. If you have it written like log base b of b to the x, that is simply just x. You should be able to recognize it and immediately pick it out. Same thing on this one. This is just x. And b to some power is 1. That has to be 0, because anything to the 0 power is 1. So just kind of know those. If you know them offhand, that's great. That helps you out in the long run. Now, if you have log base 10, that is called our common log. and that's the part that's on the calculator. Normally, it is not written with that 10, it's just log, okay? You normally don't see the 10. Log base E is called our natural log, and it normally is not written like this. Actually, I don't even see it like that, but that's what it means. We usually write it ln, okay? Natural log is ln. There's a button on the calculator that has the ln on it. So that's what you see in majority of the problems. That's the only two that are actually on your calculator. The rest you have to use the change of base theorem for. So on the next part, where it says solve for the unknown variable, okay, on this one, if you have an equation like these two with just log or just ln, then you're going to write it in exponential notation. So remember that if you have just log, this is like a base of 10 right here. I don't want you to get used to writing it there because it's never going to be like that when you see it in a book. Okay, so, but that's what it means. It's a base of 10. So this would be 10 to that power equal to x. So 10 to the 3.0876 power is equal to x. So x is, let's see, that would give you 1,223.4888. Okay, and that's a roundabout, but go lots of places out, at least 3 or 4. Okay, if you have ln, it's basically the same thing, except that's a base e, remember. So e to this power is equal to that. So e to the negative 0.9128 is equal to x. So if you plug that in your calculator, and be careful with that button. It is an actual button there. I think it's right around the log button. You'll probably have to second to get there. This is 0.4014. So just plug in your calculator, make sure you know how to do that before you take a test. As far as graphing the functions, here's the pictures of the graphs, what they kind of look like. I'm not going to ask you to graph it, but I just wanted you to know what they look like. They basically all look the same. Now this last little part is finding the inverse. And we've done inverses before this year. Remember, when you find the inverse, you interchange your x and y and then solve for the y, okay? And of course it gave you a little hint here. It tells you how to do it if you look at the tiny print. So the only hard part about this is that you have to use logs in it to be able to do it, or exponents, depending on which way it goes. So remember that f of x is equal to y. So this is like saying y is equal to 4 to the x power. So if I want to write the inverse, I have to interchange my x and y. So there we go, we did it. Now we want to isolate the y. So how do I get that y off of being an exponent? That's when we do the log on both sides. So log x, log 4 to the y. Now I can bring that exponent down. And I can isolate y by dividing both sides by what's by the y. So as weird as it looks, this is our inverse. Okay, so let's keep going. Here, if we interchange our x and y, this would be x, and this would be y. Let's see. I could probably clean this up. 3 squared, because it might make it easier. I mean, I guess I could leave it either way. Doesn't matter. And just do the log of both sides. Yeah, it's the same. Let's try it that way. We do log x equal to log of 3 to the 2y. If we bring that exponent down, so now to get y by itself, this would be log x divided by 2 log 3 equal to y. So you could do it like that. Yeah, that's fine. All right, so the next one, x is equal to 5 to the 1/2 y. Well, that one looks gross because it's got a fraction. Let's take the fraction out and write it as square root of 5. Maybe that'll help. Okay, so now we're going to do log of both sides. And I'm going to use ln this time just for fun. You don't have to use ln. You can use log. As long as it's the same on both sides, you're good. All right, so we're going to bring that exponent down. And then divide by what's by the y. There we go. All right, now notice the last two have logs in them. You're still doing the same process, but instead of taking the log of a side, you're doing exponential notation, basically. So let's see what this looks like. This would be x equal to log y plus 1. So if I want to isolate the y, this would be x minus 1. And, that kind of looks weird. So I'm going to write it, because I like to draw my little arrows. So I'm going to write it, instead of having the x minus 1 on the left, I'm going to put it on the right. Okay, because remember, this means a base 10 to this power is equal to that, if I write it in exponential notation. So this means 10 to the x minus 1 power is equal to y, and bam, we have our answer. And then the last one here, let's see. This one, can I rewrite this as ln y equal to ln x squared? Yes, I can, because remember that's just that property, that power property. Now, if you remember the one-to-one property with the exponents, for instance, if I had, say, 2 to the x equal 2 to the 5th, then x is equal to 5. Remember the one-to-one property? It's the same thing here. If you have the log on both sides, you can use that one-to-one property. So this just says y is equal to x squared. So if I take this equation, I interchange the x and the y's, then that means I have x equal to y squared. So the square root of x is equal to y. There we go. Okay, on this page, it starts the homework portion of it. So if you like to do it on your own and then just come to the ones that you need to, that is great. On these first three, these are just review of things you should have known in geometry. So if you remember, and it may help to just draw out the triangle. If this is a 30-degree angle, then this one has to be 60. We know the relationship is 1, 2, square root of 3. So if you know that, then as you go through, the relationship here, we can just say, well, what did we do? We said times 8 for this side, so this would have to be 8 times that side, and 8 times this would be 16. On this other one, this is 45, 45, 90, so we know if that side is 8, this side must be 8, so this side must be 8 square root of 2. So pretty straightforward. And number 3, oh wow, they've got 2 of them in here for you. Let's see. This one, let's see if I draw it out exactly the same. Okay, and this is the 30-degree angle. Then we have 1, 2, square root of 3, like that. So this is times 2, so times 2, and times 2. So this would be 2 square root of 3. And then on the bottom, if that's 4 square root of 2, then this one has to be 4, this one has to be 4. All right, as far as expanding the logarithms, this would go to log base 3 of a plus log base 3 of b squared plus log base 3 of c. But remember that you need to take those exponents down. So the actual finished version would be this. Okay, if you can go straight to that last step, then by all means do that. You don't even have to write that middle step. Okay, on number 5, this would be, I'm going to try to go straight to that step, and hopefully you see it. If not, let me know. This would be 2 ln x minus 1/2 ln y. So if you can go straight to the final answer, great. If not, put the exponents up there and then bring it down. Now on this last one, I'm going to clean that up a little bit first because of this exponent on the outside. So this would be x to the 6, y to the 6 over z to the 3rd. Sorry, my dog is making noise this morning. He is a happy little booger. Okay, so this would be 6 log x plus 6 log y minus 3 log z for the final answer. All right, let's see what the next one is. Rewrite the expression as a single log. Okay, so this one we're combining. This one's a little bit easier, I find. Students tend to like it a little bit better. And that would be, let's see, we've got 1 log. Remember the ones that are positive are on the top because it's multiplying. The ones negative are on the bottom. And then if you've got a number in the front, that's an exponent. So this would be a c to the 3rd over b squared. And there's only 1 log out in the front. This one would be ln, there's only 1. Okay, so on the top I've got x squared, y to the 5th. On the bottom I've got z to the 3rd. Oh wow, this one looks a little interesting because of this piece. But can't we simplify that a little bit? Isn't that the same thing as just saying 1/4 times log 3 base 3 of z? So that number is just in the front. So yeah, we can do that. So this would be 1 log base 3. On the top I've got y, x to the 7th. Oh, that's plus 2, so it's on the top also. So this would be z to the 1/4. And you can leave it like that, or if you prefer, you can write it with the 4th root of the z if you want. Either way is fine. All right, so in this next little part, they are asking us to solve the equations. Anytime you can get to the same base, you know, it's easy enough to do. So like on number 12 right here, we can get the same base because we know 10 squared is 100. And we know 10 cubed is 1,000. So you certainly can get the same base. It's much easier if you do it that way. And when you have the same base, you can use the one-to-one property, set them equal to each other, and solve from there. You know, you'll get the same answer. So you could put it as this, or you could write it as 1.5, whatever. But on the ones like this one, you can't get the same base because they just don't have it. So at that point is when you take the log of both sides, because that is the inverse of the exponent, and we want to get the exponent down. We want that x down so we can solve it. So if we do the log of both sides, whatever you do to one side, you got to do to the other. You can now use that property where you bring that exponent in the front, like that. And now to get x by itself, I just divide by log of 4. And this would be your exact answer if for some reason they asked for that. Sometimes they do, that's exact. However, they're telling us to go to 4 places after the decimal. So if you plug that in your calculator, let's see, I believe you get 1.9037. So just check and make sure you got that. Now, all these are basically the same exact thing. So what I'm going to do is just put the answers right here, and you're going to just work them out and see if you get the same thing. So basically you need to just take the log of both sides and follow that same procedure. And hopefully I'm writing these numbers correctly. Oh, look, that one comes out to a whole number. That means this is a multiple of 4. This is 4 to the x, this is 4 to the 5th. So we could have done that in a little short way, but not all of them are like that. All right, so let's go on to the next page. Okay, on this part, they are asking us to find x, y, or b as indicated in the following problems. Okay, so let's look at this part. They are asking us, it's a log, there's only log on one side, so let's write it in exponential form. I like to draw my little pieces, because remember it means this base, you know, log base 2, so that's the base. This is your exponent on the outside, and then x is over there. So x is just basically 2 squared, which in this case is 4, so that one's nice and easy, sweet. Okay, so this one is log 16 to the y power is equal to 8. All right, now this one's a little bit more challenging because now we're solving for an exponent. So you can either take log of both sides here at this point, or just get them to have the same base. And since I know this is 2 to the 4th power, and that one's 2 to the 3rd power, the easiest thing to do is that part, where you set them equal to each other with a 1-to-1 property. So y is 3/4. All right, let's see. The next one, b to the 2nd power is 16. So b to the 2nd power is 16. So I got to take the square root of both sides. So b is 4. We tried to see if b could be -4, but it gave us error messages, so that you can't have negatives on that part right there. Let's see the next one. This is b to the 0 power is 1. b to the 0 power is 1. And at first I was thinking that b would be all real numbers, but remember 0 to 0 is undefined, so you can't even do that. So that's not exactly right. And then we can't have those negatives, so now we know b has to be just greater than 0. So anything greater than 0 would work. All right, so the next one, 4 to the 1/2 power is x. So 4 to the 1/2 power is x. That's just the square root of 4, which is 2. 1/3 to the y power is 9. Oh, that's kind of weird. But we can rewrite this with the same base, because I can say this is 3 to the -1 power. So 3 to the -y power is equal to 3 squared. So y is just -2. This next one, b to the 3/2 power is 1,000. b to the 3/2 power is 1,000. Let's see, we can write this. There's multiple ways to solve it, but one way is to change that to radicals. This would be the square root of b cubed equal to 1,000. So we could take the cube root of both sides, and the cube root of 1,000 is 10. So I get the square root of b equal to 10, and then we have to square both sides, so b would have to be 100. And there's other ways to do it, so if you want another way, just ask and I'll show you in class. The next part, use logarithms to find the inverse. Okay, here's the hardest part, I think, of what we're doing, finding the inverse. That's when you interchange the x and y and then solve for the other variable. So remember, this represents y. So now we're going to put x and flip-flop and put y up there. So now if I want to solve for y, I need y as an exponent here. I need to get y down off of that, so we have to do the log of both sides. Oops. Except I said it, but I didn't write it. Log of both sides. Now the exponent can come down. And now all we have to do is divide by what's by the y to get y by itself. So this is our inverse. So it's not terrible, but it can be kind of yuck. Okay, so the next one, x is equal to 3 to the y power plus 4. So first step, subtract the 4. Now we got to take the log of both sides, and since this is a binomial, I've got to keep that together. Now the y can come down. And we can divide by what's by the y. There you go. Okay, so next one, y is equal to, nope, I need to switch it around. I'm going to just go ahead and write x is equal to 3 to the y minus 1. Okay, so first up, take a log on both sides. Now the exponent can come down. And since it's a binomial, I've got to keep it together. Divide both sides by log of 3. Now add 1. There you go. All right, let's see. I think I can finish this today, hopefully so. All right. Okay, so let's look. The next one, I'll go with a different color just for fun. I want one that's going to show up though. Okay, so this one would be x is equal to ln of 3y. All right, so if I have ln, then I have to use the e. Okay, so we're forced to use the e. So I like when I write it in exponential notation to draw my little loop, as you know. So instead of putting that x in the front on the left, I'm going to put it on the right. It means the same thing. But it just helps me to be able to do it like this when I draw my little line. Because remember, that's base e. So this actually means e to the x power is equal to 3y. So once we have it like that, we just have to get y by itself. So we divide by 3, and voila, we are done. It's actually not as bad as you think. Okay, so the next one, we need to interchange the x and y. And we want y by itself. So this one does look interesting. Okay, so this would be log x minus 4 is equal to 3 log y. Now we gotta divide by 3, so log x minus 4 divided by 3 is equal to log y. And to get y by itself, remember this is base 10, so I should write it as 10 to the, oh wow, this is going to be yuck, log x minus 4 divided by 3 power is equal to y. And that's it. That looks terrible, but normally I write that on the other side and do my loop-de-loop, you know, like I did on that one, but I'm just running out of room. All right, the next one. Okay, I can't quite see this piece. This is a challenge problem here. Wait, why did it not? Okay. Why is it not letting me erase here? Oh well. Okay, I will keep going then. Okay, on this one, I can look at it on the other page. This one is trickier. Let's see, this would be log y equal to 1/2 log x plus 2, because I'm basically dividing both of those pieces by 2. So now we have the same process as that one. So we need to interchange the x and y. So log x is equal to 1/2 log y plus 2. Now we want y by itself, so log x minus 2 log y. So times 2, so 2 log x minus 4 equal to log y. So 10 to the 2 log x minus 4 power is equal to y. Yeah, that's nasty. Okay. Don't worry about the ones as difficult as probably these two. I'm not going to give you anything like that on the test. Okay, so now the last two. I'm going to try to hurry up and get this done before I have to get off to school. Okay, so condense into a single logarithm. All right, let's write this as 1/3 log base 7w minus, oh, that one's already done for us. I'm going to just leave it. Plus, this would be 1/2 log, I should have wrote it over, I'm running out of room, running into the other problem. Sorry about that, y'all. So if I write it into a single one, I know there's 1 log base 7. This is going to have w to the 1/3 power on the top. The y squared is going to be on the bottom. But this last one, z to the 1/2 power, is on the top because it's a positive, okay? That trips people up. They want to think it's on the bottom but you're not distributing that negative in the front, so it does belong on the top, so pay attention to that. And then this last one we're expanding, so I know this is 3 ln x plus 1/2 ln y minus ln z. So once you realize what they are, it's pretty straightforward. All right, I will see you later.